So this is the color change now. You can see it from the color we started with before to this now. Now I'm seeing, so that let me read it then so that everybody can see it, because sometimes when you did not prepare the reagent very well, you might not be getting a very accurate titer value. I've always talked about that, and that's why educators, we need to understand the preparation so that our titer value will be. So I'm seeing, hello guys, you're welcome to today. Very quickly, if you are doing NECO for this year, you need to come close. Yeah, you need to come close. We want to give God glory for the WAEC we just finished. It was awesome. The practical was awesome. And I want to believe for every student that actually watch those videos, they really find it very beneficial. So today, very quickly, we are going to be looking at step-by-step titration on the NECO 2025. That's what I'm going to be doing today. So if you are doing that exam, you are a science educator, you are a student writing NECO, you need to come closer. Very wonderful titration they brought, and we are here to analyze it one after the other. As regards the reagent preparation for this year, I've had a lot of calls. I will drop the WhatsApp channel to the comment box section so that you can get updates. A lot of people are calling me, and that's the reason why we created that very particular WhatsApp channel, to actually be able to disseminate information to students alike and to teachers. So if you are not there yet, I'm going to drop a link in the comment box section for the WhatsApp channel so that you can join it and you get updates. You have been giving them updates back to back about all the exam that we have been writing. So if you are not there, please, you need to be there. And very important, if you look at the practical for this year NECO, we have two reagents that is acting as the base. But I've said that on the channel, there is nothing to worry about. The two cannot react. I've said that before. It is only one of it that will react, because the acid we are working on is HNO3, and we have both sodium carbonate, you get, and sodium nitrate. So the sodium nitrate there is just like an impurity, okay, because the sodium nitrate there will not react with HNO3. But we are going to give more updates on the WhatsApp channel, so please try and join me. So today I'm going to be doing the practical like we normally do, and I've said that before. Just understand the steps. You are less concerned about the way they are bringing the question on that day. What you need to know is understand how this thing are being done. They can change the question, they can decide to maneuver you, but if you understand all these things, you will still get the maximum mark for the practical. So pay attention very quickly. This is my own predicted question for the exam, like I always tell you, but you need to go about it step by step. You need to watch the video over and over again for you to understand what we actually do. So you're welcome. If you are just watching this channel for the very first time, kindly subscribe, then turn on the notification bell so that when you upload any video, you are going to be notified. So come close, let's look at the predicted question for NECO for this year. You get that? They said A is a solution of 0.0100 mole per dm cube, okay, mole per dm cube of what? HNO3, and B is a mixture. Now look at that. B is a mixture of 8.0 gram of sodium thiazocarbonate 4 and sodium thiazonitrate 5 in, let me add that, in 1 dm cube of the solution. Of course, for a lot of people that have reached out to me about the preparation, you are not preparing it separately, please. You are not preparing it separately. You are preparing together in 1 dm cube, and that's why I said you should join the WhatsApp channel so that I can give all those procedures and tell you what to do so that we can be ready for the exam. So B is a mixture of, you can see that. So the B now, this very particular B, is a mixture of sodium carbonate, right, and sodium nitrate in 1 dm cube of the solution. Put A into the burette and titrate against 20 or 25 centimeter cube of B using melty orange as the indicator. Okay, repeat the titration to obtain consistent values, tabulate your readings, and calculate the average volume of acid used. Now, if you come to the equation, you will see that the acid is reacting with only the sodium thiazocarbonate because the sodium nitrate is acting as a purity. Do you get that now? So the sodium nitrate there is acting as the impurity. So the one that is reacting is the sodium carbonate and the what, and the nitric acid, which is the HNO. So I'll quickly do the titration. We have been doing titration on this channel, and I want to believe that should not give us problem by now. I'll just do 1 or 2 of the titration. I've even taught on this channel how to prepare your table when you already understand what you are doing, right? So I'll just do 1 or 2 of the titrations, then we'll go to the calculation. Very simple, just pay maximum attention. So come closer, let's see. So I have this. I'll fill the the burette to 0 already. So let's have our burette readings like we normally do. Let's have our burette readings, okay? Height in centimeter cube. Let's have the rough, okay, in centimeter cube. Like I always do, the first in centimeter cube and the second in centimeter cube, okay? So we have this already now. Please take your time to tabulate your readings, very important, okay? So let me do it like this. So we have here to be the final readings, right? You have the final readings, you have the initial readings, okay? Then we have the volume of acid used. Okay, so let's tabulate them, right? These are important steps to take. Okay, so we can now have that. Our indicator, let's tell them because they have even told us the indicator to use. So we can do our metil orange, right? And our volume of pipette, the volume of pipette, let's specify the one we used. So let's say we use 25 centimeter cube. So we are using 25 centimeter cube. Okay. Now, for our initial readings, I've told you I don't want you to stress yourself. You get? So we are just telling them that we refilled for every time we perform the titration. We refill. So I'll just do like 1 or 2, then I'll fill my table. I've given you those techniques on this channel. So if you are just new to this channel, you need to subscribe and turn on the notification bell so that when we drop any video like that, you are going to be notified. So I have filled to 0 mark already. Okay, then I have my what? I have my pipette. This is my B. So let me quickly pipette. I've been doing this on this channel, and you know, one thing about this channel is we want to do it so that you see it. Okay? Good. So we have prepared this already. For science educators, you know the preparation, you have been given the instruction already. The instruction has been sent to school. If you don't have it, join the WhatsApp channel so that you can get the instructions, you can get the updates there. So, very important. So, our metil orange now, these are metil orange. So, I'm using just 2 drops. 1 and 2. You can see the color change now. This is the color change. So, let's go with our titration now. So gently, just watch. Still going. You see that now? This is already changing. Let's add a bit. Good. Did you see that now? Did you see that now? Did you see the color? So this is the color change now. You can see it from the color we started with before to this now. Now I'm seeing 26. Okay, let me turn it so that let me read it then so that everybody can see it. Because sometimes when you did not prepare the reagent very well, you might not be getting a very accurate titer value. I've always talked about that, and that's why educators, we need to understand the preparation so that our titer value will be. So I'm seeing 26.30 here. So let me turn it for the camera so that you can see it. Now look at that. This is 26. Can you see? This is 26. Did you see? Did you see 30 there now? You get that now? Very clear now. From my titration now. This is 26.30. So that's what I'm using. I don't want to do a whole lot of time. We have been doing titration on this channel. We have had a lot of practicals where we do titration upon titration. So 26.30, you can see that now on my bullet. So I've set these two on my channel. That's what I want to use. So since I got that, I can bring this to be 26.30, which is what I actually got, okay? Then I can bring this two to be 26.30 because I have to have consistent values that are marked for that. Then because this is wrong, I can just decide to say, let me put this to be 50. Did you get that now? So from there, I can now have 26.50, 26.30, 26.30. So I'll be using these two. I'll be using these two as the average. That's the reason why, when you're titrating like that, if it is for students, please, I would advise you to titrate it at least 2 or 3 times. You understand? You can do 2 or 3 times because you might not actually be perfect in titration, but I don't just want to waste a lot of time. I'll be doing a lot of titration on this channel. Check every of our video every year. We are always dropping video on titration for NECO, for WIRE, you'll get. So I don't want to waste my time. That's why I'm doing this. So from here now, we can now calculate the average volume of acid used, right? I said I'm using these two, right? So I can have 26.30 plus 26.30 divided by what? By 2. So our average volume of acid will still be what? 26.30 centimeter cube. I want to believe this is clear. Very clear. Very clear. That's if you have titrated well. If you're a student who are just learning titration, you can carry the titration out multiple times so that you will understand. Okay? Very clear. Now, from this now, let's come back to the question. They said calculate your readings and calculate the average volume of acid used. That's what we have done from our titration now. Okay? Then, from your result and information provided, calculate 1. Concentration of B in mole per dm. Now, come close now. Look at that. B is a mixture. Did you see that? B is a mixture of this sodium thiocarbonate 4 and what? Sodium nitrate. But they're now saying calculate the concentration of B. And I said something before I started that this one will be the one that is reacting with the HNO3. Does that make sense? So I'm calculating the concentration of this now. So if you look at the question, they did not give us any hint about B because it said B is a mixture. The 8 is the mixture of this and this. So how do we calculate concentration of B in mole per dm? I can use my formula. We have always done that. CAVA over CBVB equals NA over NB. Right? So what is the concentration of acid? It's given in the question already. 0.100 times what is the volume of acid? We have gotten that already. That's 26.30 over CB now. We are looking for concentration of B. Is that not? So our CB is what we don't know. Times our VB. That's the volume of our pipette, which is 25. Is that not? Equals to our number of moles of acid. We come to the equation. Acid here is 2. Base here is what is 1. So we have 2 to 1. We have 2 to what to 1. So from there, making this the subject, we're going to have CB equals 0.100 times 26.30 times 1, okay, over 25 times 2. So our CB is equal to what? Let's have our calculator. You can see, very easy. Just follow those steps. Follow those steps and you are good to go. That's why we're always doing this on this channel. 0.1 times 26.30, okay, divide by 50. That's 0.0526. From my calculator is 0.0526 mole per dm. It's correct. This is done now. I want to believe this is clear, very clear. That's why I'm always simplifying all these things. No ambiguous terms, no bogus terms. Just straight to the calculation with simple terms. Okay. Now look at something. Please pay attention to this. You know, say mass of Na2CO3 is 250 centimeter cube of B. Look at that. Mass of Na2CO3. Don't forget that the B we calculated is our Na2CO3, right? Now, what is the meaning of this? It's 0.0526 mole per dm cube, which means you have this mole in 1 dm cube. That's the meaning. And And what is the meaning of 1 dm cube? 1000 centimeter cube. So, but they want us to get the mass now in 250. So what do I need to get? I'll first of all get the mass in 1000 first. Let me get the mass in 1000. When I get the mass in 1000, I can get in 250 because this is already the mole in 1000 centimeter cube, which is 1 dm cube. Do you get that now? So I can do for number this one. For 2 now, I can say concentration in gram per dm cube. Right? I can say my mass is equals to mole times molar. If you are used to this channel, you should know where I got this formula from. Where did I get this formula from? It's from mole is equals to mass over what? Molar mass. Did you get that now? And I'll make mass the subject. So molar mass times mole. That's it. So the mass becomes our mole. Did you see that? 0.0526 times molar mass of sodium carbonate. They would have given us Na to be 23. Let me write it here so that we can use that if we want to. So Na is 23, C carbon is 12, oxygen is 16, nitrogen is 14. You know, anyone we actually want to use, they will always give us all this. So let's go back to that place now. So we have Na2CO3 now. So Na2CO3, that's 23 times 2. You get that now? This is what we are doing. I will raise this back so that we can see it. Na2CO3. So Na is 23 times this 2 plus carbon is 12 plus this 16 times 3. I want to believe we are still here. So from here, our mass becomes 0.0526 times, this will be 46 plus 12 plus 48. Let's have a calculator. Help us with that. 46 plus 12 plus 48. That's 106. So we have our mass to be equal to 0.0526 times 106. So our mass will be equal to 0.0 times 106. 0.0526 times 106. That's giving us 5.57. So let me just do that. 5.57. 5.57 gram per dm cube. Did you see that now? 5.57 gram per dm cube. Now look at something. You know this is 5.57 gram per dm cube, meaning we have 5.57 gram in 1 dm cube. Did you see that now? But the person is saying that we should get in what? In 250. Did you get it? So I can now say 5.57 gram. We have it in what? In 1000 centimeter cube. So in 250 centimeter cube, this one will be what? Will be x, right? So we cross multiply. You have x to the 5.57 times 250 over 1000. Over 1000. So 5.57, 5.5. Okay, let me even do that again. I think for the approximation, so that will be right, times 106. I saw something now. Okay, that's 5.575. So let's just say 5.58 approximately. So let's approximately, okay. So this will be 8. Did you get that now? So 5.58 times 250 times 250 divide 1000. That's giving us 1.395. So let's just say 1.40. So our x is what? 1.40 gram in 250 centimeters. I don't know if that is clear. Now look at this. Let's assume that giving us mass of Na2CO3 in gram per dm cube. This is just where we're going to stop. Do you understand that now? If they are giving us mass of Na2CO3 in gram per dm, concentration of Na2CO3 in gram per dm cube, would have stopped here. But they didn't say gram per dm cube, they said 250. So after getting in 1000, we'll now get in 250. I want to believe that is clear. Right. Okay, let's move on. Let's move on. So from there now, the next one, they said 3. Mass of NaNO3 in the mixture. Don't forget, the mixture, the mass of the mixture is 8, right? Which means the addition of the mass of this and this will give us 8. That's the meaning. But now we have gotten the mass of what? Of Na2CO3. Did you see? Look at it. 5.58 in gram per dm. So we can say, come closer please. We can say now that mass of Na2CO3, this is the third one please. Mass of Na2CO3 plus mass of NaNO3 is equals to what? 8 grams. Is that not what they said? Yes, now. They said B is a mixture of this. Now we are putting the mass of Na2CO3, right? In gram per dm. Did you see that now? Why are we using gram per dm? Some people say, sir, why are you not using 1.40 gram? Why are you using 5.5 gram? I'm using 5.5 gram because it is already specifying the question that is in 1 dm. Did you get that now? So mass of Na2CO3 is 5.58. So we have 5.58 plus mass of NaNO3 is equals to 8 grams. Is that not? So I can take 5 to the other side. So I have mass of NaNO3 will be 8 minus 5.58. Did you see that now? So mass of NaNO3 is equal to 8 minus 5.58. 8 minus 5.58. That's giving me 2.42 grams. So mass of Na3 in this is 2.42 grams. Did you see that? Now, how do you know you are on the right track? If the mass I got for this one is more than 8, I will know my solution is wrong because the mixture of the two is 8. So there is no way I will be getting the mass of this to be higher than 8. However, I have said this before. Our values might be different a bit because of our title values. I have said that. But I have always said that on this channel. All these people are not really interested in that. What they are interested in is our steps. I might decide to use your own title value might be different from my own, but the steps are still the same. Though our answer will vary, right? But the steps is what we are marking. Don't be surprised. I've seen questions, in fact, the alternative B of WAEC. They change the acid from what it's supposed to be. You can't query them. They are not interested in all that. What they are interested in is the calculation. What is your step? How do you get the mixture? How do you calculate in 250 centimeter cube? The title value might vary, but the steps will remain the same. So neglect all this title value issue. The title value in my school is this. The title value in my school is that. No. The steps is what we are interested in. If the steps is right and your teacher is saying the title value in that school is this in the instruction, you are good to go. I want to believe that is correct. Okay. So that is that for the number 3. Very clean solution. That's that for number 3. So the next one now, they said the what? The percentage purity. Of course, because your sodium nitrate here is serving as impurity. Did you get that now? So they said, what is the percentage purity? So which means this NaNO3 now will be serving as impurity. So we cannot use it to calculate purity. We will use this for purity, then sodium nitrate for impurity, because it's acting as impurity in that very particular solution. I don't know if that is clear. Let me rub off this. Okay, I don't want to rub off this. Let me rub off this place, this part, because this one's on. Let me rub off this part so that the questions will still be there. Okay, so are we still together now? Okay, so the next one now, for percentage, you can see that now, percentage purity. So we have said this is the one that is acting as the impurity. So definitely this is the pure. So percentage purity, how do I calculate that? It will now be, what is the mass of the one that is pure, which is sodium carbonate, over the mass of the mixture. Did you get that now? The mass of the mixture times what? 100 over 1. Did you see that now? So percentage purity will be equal to, what is the mass of Na2CO3 that we have calculated? 5.58, right? So 5.58 over, what is the mass of the mixture? Is given in the question already. 8 times 100 over 1. Let's have that calculated. That's why if you follow what we have been saying on this channel, you should not find questions difficult. You should not. So divide 8. That's giving us 69.75. That's approximately 70%. So this is what 70%. Please remember to put your percent because you are dealing with percentage purity. So that's the percentage purity, right? So what is the percentage impurity? You can be asked that too, which is the last one. The percentage impurity. I can do this in two ways. Percentage impurity. I can do, since the percentage purity is 70%, I can do 100 minus 70% to be 30% for the percentage impurity. Yes, it's correct. Since it is percentage purity, percent is in 100. So if the purity is 70, it means the impurity is 30. But I've said that the mass of the sodium nitrate is 2.24. But let's have the formula so that we can get our formula. So we can say mass of NaNO3 over the mass of the mixture, right, times 100 over 1. So our percentage impurity becomes the mass of NaNO3, I've said that before, 2.42, right? So we have 2.42 over the mass of the mixture is giving 8 times what? 100 over 1. So you can now use a calculator for that now. 2.42 times 100 divide 8. That's 30.25. We are approximating to whole number. So 30.25, that's 30%. So it's 30%. Can you see that now? Very clear. Very, very clear. I want to believe this is clear. So you can share this video. You have a friend that is writing NECO. You can share this video to the person, right? So study this over and over again. This is just a prototype of what we feel that they are going to give you guys. Same steps. Your titer value might be different from mine. Still same steps. Percentage purity, same formula. You understand? So even if it differs because of our titer value, you are still correct. So don't forget to share this very particular video, like it, comment, and analysis for this year. You want us to make a video on the SWOT analysis for NECO this year, you can put it in the comment box section that we should do that, and we'll see how much. So if we see a lot of people that is responding, because the reagent this year are very, very expensive. The one NECO brought are very, very expensive. So but if you want us to make a video on that, the SWOT analysis for NECO 2025, you can put it in the comment box section that you want us to make a video on that. We love you guys. Thank you for the prayers. Thank you for the word of encouragement you have received from a lot of our subscribers. We love you. God bless you. You are just watching this YouTube channel for the very first time. Kindly subscribe and turn on the notification bell so that when we upload the video, you are going to be notified. Don't forget, you want us to do the SWOT analysis for this year, put it in the comment box section. And if we have a lot of people that actually, responded, we are going to try to make a video on that. Thank you. God bless you. Bye for now.